All right, folks, we're talking about buffers, acid-base buffers, and we're going to now look at the carbonic acid hydrogen carbonate buffer in blood. All right, so how is blood pH maintained at such a narrow range? The primary blood buffer is a combination of carbonic acid, H2CO3, and hydrogen carbonate, HCO3 minus. And I like the annotation on this chemical equation here. It says, H2CO3 comes from CO2 produced in the cells, and hydrogen carbonate ion comes regulated by kidneys. So we could add another equilibrium here. Right, that carbonic acid can come from CO2, which comes from respiration in the cells. So this is how the body can work. Oh, actually, you know what? That's my next slide. There we go. Carbonic acid forms from CO2 and water in a combination reaction. It is reversible. It's equilibrium. And so if we put these two reactions together, we get the full equation here. Right? Two equilibria, and carbonic acid plays the central role in this. Right? We have two equilibrium, which both include carbonic acid. So one is between CO2, again, from the cells and respiration, and the other one includes hydrogen carbonate ion regulated by the kidneys. And here's the key. This also includes the hydronium ion, which is used to calculate pH, right? Here's my own extra notes on this. So the lungs affect carbon dioxide levels, kidneys affect bicarb levels, and they're all connected through these multiple equilibria, and hydronium is right here. So the pH balance is maintained by the lungs and the kidneys. And remember, when there's equilibrium, there's Le Chatelier's principle. All right, so here's that equation at the top, and then we're going to look at acidosis and how this can come about. So there's two ways, and we're going to be looking at basically coming from each direction of this equation. So respiratory acidosis is breathing weak and shallow so that carbon dioxide is not exhaled enough. Okay, so we're not exhaling CO2 enough. It's starting to build up in the blood, and so that would cause a shift to the blank, right? So think about equilibrium and the Chatelier's principle. If CO2 goes up, that will cause a shift to the right to produce carbonic acid, which would then cause a shift again to the right. So the concentration of H3O plus is increased, and the pH goes down, right? So now we just explained the mechanism behind respiratory acidosis, which can be caused by head injuries, emphysema, asthma, drug use, something right that might lead to weak and breathing, shallow breathing. Okay, let's look at the right side. Metabolic acidosis. If the kidneys do not release sufficient bicarb, right? So the kidneys are supposed to release bicarb, and if they're not up for the task, right, the concentration of HCO3 would go down. What happens to the equilibrium? right? It's going to shift to replace it. But of course, not only hydrogen carbonate is produced, also H3O plus is produced, right? This entire thing, the products are produced. So this leads to increasing H3O plus and decreasing pH. So again, we just discovered the mechanism for metabolic acidosis, why pH would go down. This might be due to kidneys not working, kidney failure, uncontrolled diabetes, starvation, right? Okay, so that's acidosis and using the carbonic acid cycle. Now, let's look at, oh, there we go, there's the answers. Alkalosis, right, is if the pH goes up too much. So let's look at these two cases again through the lens of the buffer system, equilibrium, and Le Chatelier's principle. So if rapid breathing removes too much CO2, carbon dioxide level goes down, causes a shift to the left to replace it, concentration of hydronium goes down, and the pH goes up, right? So, right, rapid breathing, hyperventilation can cause this, caused by anxiety or any other reason. Altitude sickness, intense exercise as well. If you recall, I think an example at the beginning of the chapter had to do with a marathon runner. We might return to that. Metabolic alkalosis. Let's look at the right. So in this case, if the kidneys do not remove enough bicarb from the blood, so they're regulating that, they can add or remove it. So if bicarb levels get too high, right, it's going up, then this would cause a shift to the left, right, which would lead to decreasing H3O plus and thus increase in pH. Reason for this could be excess vomiting, excess usage of antacids, or adrenal gland disease. And let's see, there's the answers. Right, so it's useful to understand the chemical equations happening here, the central role of carbonic acid, this buffer system that's in place, and the physiological mechanisms in place to control the buffer system. Here's just another way of looking at it. Here, let's say you have a problem. Well, yeah, so actually last time we talked about what causes it, and now we can talk about what to do about it, right? How do we reverse this? So if alkalosis is the problem, it means pH is too low. There's too much H plus. We need to decrease the amount of H plus. How can we do that? One is, well, not like we have control over it, but the kidneys can release more bicarb, right? Releasing more bicarb would shift the buffer system equilibrium away and consume H plus, or more likely, and increase respiration in the lungs, right? That's going to draw out more CO2, so the system will shift to replace it, thus consuming the excess H plus and bringing the pH back to a normal level. So the reverse of what caused it, right? We could do try to increase respiration. Kidneys could release more bicarb, And if that's not possible, right, we can do something about this. And this was actually the example of the runner, I believe, where they gave an IV infusion of bicarb, causing a shift, and the system stabilized, right? So you have some external interventions that we can apply. Okay, alkalosis, the pH is too high. You need to increase H3O+. What do we do? The opposite type of cases, right? Bicarb is, we need to get rid of some bicarb, maybe excrete it through urine. We need to try to raise the CO2 levels, decrease respiration lungs, right? Slow down breathing, shift things this way to produce more H plus and bring the pH back down to a normal level. So the idea of like breathing into a paper bag, right? The reason that works is that you exhale CO2 every time you exhale, and if you breathe into a bag, then you're now inhaling it back in. So the air that you breathe is actually CO2 richer than normal at least, and that can help bring CO2 levels back up. Also, an IV infusion of dilute acid will do the trick as well. Just simply put in, get H plus in the system by itself. Okay, I have a few questions here, and we'll wrap it up. So answer the questions below about the effects of hyperventilation. And as always, right, we're thinking about it in terms of the chemical reactions and the equilibria that are there. So does the concentration of CO2 dissolved in the blood increase or decrease in a patient who is hyperventilating? And this would be a great time for discussion, but we can't do that here. So you know what? Why don't you just pause it, take a look at these questions, read them for yourself, pause it, and when you come back, I'll just show the answers. Okay, do that now. All right, so if a patient is hyperventilating, the concentration of CO2 decreases, right? They're breathing it out. The change in CO2 concentration, how does that affect pH? Well, if CO2 decreases, then there'll be a shift to the left to correct for that, which decreases the concentration of H3O plus and raises the pH, which means it would cause alkalosis. So when a person hyperventilates, in which direction does equilibrium shift? It's shifted to the left to cause that. And then how does it breathing into a paper bag reverse the effects? We kind of mentioned that before. The air will have a higher concentration of carbon dioxide because you're capturing the exhaled air. So as more carbon dioxide is breathed into the lungs, it enters the blood, causing the equilibrium to shift back to the right. Okay, and that did not format very well. I think I actually just I typed up the questions myself, so ignore that thing at the top. Okay. Answer the following questions about a patient entering the emergency room presenting with weak breathing and respiratory acidosis. All right, so we've already given you the diagnosis. We think it's respiratory acidosis. They're breathing weakly. What do we do about it? So again, read these for yourself and then answer for yourself and come back and I'll briefly wrap up here. All right, so respiratory acidosis, the patient's blood pH is below normal, which means the concentration of H3O plus is higher than normal. And let's see, as a result of the weak breathing, in which direction has the equilibrium shifted? And explain why this occurs. So weak breathing means more CO2, which would cause a shift to the right, because CO2 is not being exhaled enough. You're asked to give the patient an IV infusion to help. What do you give them? What do you give them? And how does the equilibrium shift when you give them whatever it is that you give them? Well, if we give, there's too much H3O plus, right? So if we give some hydrogen carbonate, it will cause a shift to the left, which will take H3O with it and bring the concentration back down and pH back up. So it'll give bicarb, shift to the left, decrease H3O plus, bring pH back up. Okay, that actually wraps up what I have for this. So, all right, we spent time introducing buffers, and then this entire part 2 was about the central role of carbonic acid and the carbonic acid bicarb buffer system in blood, and how it works, how it explains changes in pH, how it maintains pH, and we can use the chemical equations and what we know about equilibrium to make sense of this system. Okay, well, that wraps up chapter 9. Good job, and see you next time.